Let's begin by installing Air devices. We can first open the project file to see the supply Air devices that we have in the project at the moment. They are listed here, and here you can see the ventilation entry in the project file and the product category supply devices here. From here we can enter the MagiCAD cloud library if we need more devices. And now here we can see that since we entered the cloud library from the supply device category, that is also where we land here in the cloud environment. And we can start filtering out the products that we want. For instance, by defining an operation point by flow, let's say 26 liters per second, and defining a minimum and maximum pressure levels, let's say from 10 to 30. This is the number of products that we get, and we can still narrow down the selection a bit by defining a connection size, like here duct connection diameter, let's say from 100 to 199. That also restricts the selection a bit, and further on maybe select the installation placement, in this case maybe ceiling. So there are still quite a few products in this selection. But here we can now take a look at one of these devices, a ceiling installed user. By the technical data we can see here that the operation point and the pressure minimum and maximum that we defined land in between the diameter curves here. So we get an idea of its performance with the flow that we defined. If we are happy with this, we can insert this product into the project. Give it a code, a 2D symbol if we like. Here we have all the market area symbol databases selected. Let's restrict that a bit to generic, like this, and just click on OK. Now the product is available for us to be used. We zoom in a bit. Here we have an office building with some offices and meeting rooms. Here we might have defined a supply air flow for this meeting room here. So let's begin the device installation by going to this air device tool here. And so let's just go on and select the device that we collected from the cloud. Here we have all the air device categories as tabs, and now we're in the supply device. So let's take the one that we selected. Here we could, if we wanted to adjust the color length, we could do that, as well as the grill direction. So here are the available sizes, and here we define the flow, the symbol, and with OK we can install the device. I have my snap functionality on at the moment, so that helps me then when it's time to connect the ducts to devices. Let's just rotate the device a bit and install a couple of devices here. System selection here first. We can also define a status or the installation code if needed. And here as well, we might want to use existing objects in the model to align our installation with the existing one. So here we can take a reference object from the model and in that way update the installation elevations. When we're good, click on OK. Select the other device here. Here we can also see the properties as well for the device. And double clicking also opens the part properties. At the moment, the operational point lands here to a minimum pressure level. Here from when we click on objects here we can see some handles. There's the plus handle and this asterisk where we can create a new instance of the same device. Rotate it and place it again. Like this. We have now installed a few terminal units here. We also have a riser duct, and now we can start drawing the duct network. Let's first take a look at the project file. We have here duct series, where we can define what kind of ducts we want to use, define their sizes, roughness value, general information, and the fittings that we want to use. We can here edit the list and collect the set of fittings that we need. Here I have a basic circular duct series. Now starting the duct drawing happens here. A dialog pops up for me where I can choose the series, the size, and the preferred fitting types, for instance for bends, the length of the fitting, for rectangular ducts, the bend type, and if I want to use tab colors or T-branches, the reducer length, or when a circular duct meets a rectangular duct, what kind of fittings are used then. Even though I'm using tab colors, I will break the main duct now into segments always when I connect a branch to the main ductwork. Also, when there's a height difference, I can here select which angle I want to use. So let that be 45 now. And we can start the drawing. And when first time clicking on here lets me select the system and the elevation. So let's start drawing. I have the snap functionality on, so that helps me to align the different ducts, and I can make the connections like this with the correct fittings. Here now connecting the devices, we had the handles here in each object. The plus handle automatically starts the duct drawing, and I had the tab colors selected, so the fitting is generated, and here you can see the different segments of the main duct run. I have different handles here for the ducts as well. This asterisk creates a similar object, and I can start drawing from the main duct as well. I want to keep the active setting, which is the 125, and not select the same size as the main duct run is. Here we can see that now that we draw from the main duct run, the software made the 45-degree angles in the middle. Let's connect the rest of the devices. Here we can see again the 45-degree angle. Let's take a look at the 3D picture as well, like this. Also, we can use the handles to transform bends to branches and draw it like this. When the duct drawing functionality is on, I have here a selection of different options that I can use. Like with the Z selection, I can make a elevation change. I can use a standard connection to connect two open ends to each other, or for instance with the device functionality here, I have the same selections behind the right click. So use the device to install a device right at the end of a duct. But now let's take the Z for elevation change. It lets me choose the angle and the elevation. Let's say we might inherit an elevation from existing objects as well. So for instance, maybe with a tolerance, go below the bottom of an existing object and continue drawing. Here we can see the elevation change in 3D. We can remove open ends, so the software automatically makes them as bends there. Also, now that we have a simple duct network ready here, we might want to run a collision check. And select what kind of objects are checked against each other. In this case, we could just, for simplicity, check ducts against ducts. Select the area. The report gives us 3 collisions. They are marked with the yellow cross. How to avoid these clashes? For instance, here it might be difficult to see if there's a clash or not, just like that. So what we can do in this case is we can try and avoid the clash by moving the objects. So this horizontal duct here, we can run move and use the Z option to make a change, make a movement in vertical direction. First, we select what we want to move. In this case, we can have the tolerance there go below the bottom of the yellow extract duct. Take that as a reference. We can see the updated elevation information. And now if you look at the 3D picture here, you can see the slight movement of the red branch here when I click OK, like that. We could do the same for this duct here. Exactly, now I have the horizontal move, but I can still select the Z and do the same. Go below the bottom of the yellow duct and click on OK, and it changes the elevation a bit. Now the elevation of the terminal units changed as well. So what I could do here, if possible, I have here a color length. So the diffuser, I could adjust the diffuser to be, instead of 100 millimeters, to be, let's say, 30 millimeters. So while the branch is now lower, we can still adjust the diffuser to be placed a bit higher instead. So these small adjustments we can do. We have another collision here. If you cannot move the duct, then we can also make a crossing. Let's, by the way, clean the red cross here. So we can also make a crossing with the crossing tool here and define 2 points between which to make a crossing in a plan view. So I'll select the object, and the reference duct would be the yellow one here. And the tool gives me a default option here with the 90-degree angles and the elevation. If there's enough space, I can also use other angles here. But that might not always be possible. So I can select here, for instance, the 45-degree angles and click on OK and accept the crossing. We have built up a small ventilation network, and we can go on installing components such as dampers. So let's first take a look at the project file. Here under ventilation and parts, we have all the components listed here. So they are dampers and silencers mainly, also other components. They are listed here in the project file. So these are the products that we have available in our project. And here we can see the properties of each product, like the different variants here and their performance diagram. Alternatively, we can always go to the cloud environment to see their properties there using the linked properties. So installing the components happens here. We can select between the different categories, subcategories here. Let's take a flow damper, for instance, and browse through the different options here. So there's the different variants here available. So what we can do here, we do not have to select the correct size here, but the installation tool selects the variant according to the hosting duct segment where we are going to install the device. So if there is a matching size available, then that is the size that we get. Here in the 3D view, we can see how it looks like. Also, the components have their handles, so we can take, using the asterisk, create similar, and continue placing the components. Let's take a silencer. So here, the components, obviously, they need the space. So, for instance, here, we would get a warning if there is not enough space for the component to be installed. So let's put one silencer here as well. We can also place a component to a vertical segment. So for instance, a fire damper. Let's take a rectangular component this time. And first, since there are several different objects on top of each other, when looking in the plan view, there's a block, T-branch, and so on. So here we have to identify the correct segment that we want to use. Here we can see the height level from floor level 0 to 2.5 meters roughly. So here we can see that this is the segment where we want to place the component. Select that, and then the next thing is to type in the elevation, and there it is. Here we cannot see the component in the plan view, but let's see there. Rotating the 3D view, we can see that it is here. Sometimes we have a component that needs to be rotated in a certain way into a certain direction. For that, we can use the 3D rotate from the modify tools. We select the component, and by rotating the cursor, we can see in the 3D view the position where we want to have the component. And deleting components leaves the hosting duct segments intact like this. We have proceeded to a phase where we can start sizing the ducts and running pressure calculations. Let's first take a look at the project file again. Here we have to do some specification first when it comes to the sizing method to begin with. So if we're, for instance, using this velocity-based sizing method, here we can define the duct sizes and what is the maximum allowed velocity for each size. Here we can use the static regain method and choose to keep the connection duct sizes. So the connecting duct is not sized then at all, but it follows the device size. And for rectangular ducts, we can set the minimum width height ratio, for instance. Then there is a balancing method. So this has to do with the pressure calculations. So here we can define some minimum and maximum levels for pressure in flow dampers and devices, as well as if we want to limit the damper position in flow dampers or devices. Then let's take a look at the systems. So here in supply, for each system, we can, here in the calculations tab, we can define the used sizing method that comes from the section that we just looked at, as well as the balancing method. And further on, we have three different methods that we can use as a starting point for the pressure calculations. I'm using now the minimum pressure. If we had a fan in the system, we could use that, or we could give a specific feed point pressure for the system. Here we can define the root sound power levels, and also we might want to modify the air properties as well. So we have here the air terminals, and so far there are no damper position values here, either for flow dampers or the device dampers. And on top of the devices, I have here a so-called connection node that can be used to simulate a network that is yet to be modeled. So we can here define a flow and pressure level condition so as to simulate the consumption from this point onwards. So we can run for that like early phase sizing of the duct network. Let's go here in the calculations section and start the sizing. Let's do a system-based calculation for the supply network here. Check the box for showing the calculation report so we can see what happens there. And the sizing method here comes from the system. We could override the system selection here as well, but let's keep that for now. So OK, starts the calculation. And we get to see the calculation report with a column about the so-called old sizes, and next to it the new calculated sizes side by side. On top of that, we have the airflow rate, velocity, pressure drop per meter, and the used sizing method. Here we can see a branch with a warning about velocity. So the allowed velocity is exceeded here in the branch because the setting keeps the connection size from the device. So therefore, a situation can occur that the sizing criteria is not met. If possible, we can select a new duct size here to get rid of the warnings. We'll just update the sizing. And here we can see that the report got updated, and now the velocity dropped below the maximum limit. So here we can actually do things in the report. Apart from setting a new duct size, we can also select an entirely new sizing method, or even set insulation if needed. And here we also have the general results with some general information about sizing methods and the system. In the preview picture here, we can see that there's networks from two different drawings, even though I only have the floor 1 open here. So this is coming from the second floor, and these drawings are connected to each other with a specific node that the tool can read. So we can still run the sizing even for drawings that are not open at the moment. I'll put the duct size back and click on OK and update the new calculated sizes to the model. Here we get another warning about the high velocity, and also there is a warning about the position conflict. So sometimes when the duct size changes, usually when it gets bigger, then it might be the case that not all the fittings get enough space there in the network. So we might have to do some minor modifications there, but we will get a yellow cross that highlights all the issues in the network. So if we take a look at the main duct here, that is now 250. So when we update the new calculated sizes to the model, we will see that there will be reducers and the duct sizes will change like this. And here we can see the highlighted problem points in the network. But we will accept that for now. So the network was sized now, and therefore we can continue with the pressure drop calculations. So let's take the balancing now and run it for the same system. And this time it is a bit more detailed report with If we can take a look at the pressures now. So here we can, in this column here, we can see the total pressure and the pressure drop in each object. Going down to the devices here. For devices, we can see their adjustment values, or the so-called damper positions, as well as for the flow dampers, of course, as well. By taking the product properties, so here the operational point is there in the middle, and we can see that the flow rate is 100, so the network is more or less in balance. And for the device as well, we can see the performance of one individual device. Index root is highlighted as green. And we can also just take a look at the index root alone. Okay, update to the model. And there we are. And now here we can see that the damper position values here as well, both for the devices and the flow dampers that are calculated. Let's move on and look at some editing tools. We have the edit section here, and these tools are mainly used for modifying the network afterwards. So we might need to, for instance, select a new sizing method for a part of the network, or add insulation. So let's take a look at what we can do here. If we take part properties from a duct segment, we can see here that the sizing method here is by system at the moment, like we remember was set in the project file. But if we might need to change that for some part of the duct. So we can do that here. We'll just select the property, sizing method, select that, and let's take, for instance, this one here. We can choose the range, but in this case, we'll take a manual selection, and it's not very well visible here, but here it says, here we have options here in bottom left corner. In this case, if I want to select the main run here, I will choose this between option here. So I will select E and select two objects in between, and then the tool selects all the objects there on that are between the two, and with enter I will run the command. And now if we take a look at the sizing method again, we can see that we have now the sizing method there that we wanted. In the same way for insulation, we can take insulation series and again select the objects, and the insulation appears now there. Here, as an example, I could show you the install partial insulation. If we do not want to cover the entire duct segment, we can just select the region where we want the insulation to be, and there it is. We might need to split the ducts into standard lengths. That we can do with this tool here. The cut lengths coming from the project file here, and let's run it for this current drawing, and we can take a look at this yellow extract duct here. There will be a joint part, and the duct segments are split according to the specification that we've made. We have branch tools. Copy branch helps us speed up the design so that we don't always have to model everything from scratch, but we can copy existing elements even with the tags here. So that makes the modeling more convenient. We have installed terminal units, components, and drawn ducts. Now we can move on to placing dimension texts. And let's take another look at the project file, where we have, under each discipline, we have the dimension text sections here for each product class. And here, for instance, if we take a look at the air devices, these are user modifiable text formats, so we can create as many as we like, but let's now modify one of these. So here we have a air device dimension text, and let's just edit this a bit, and let's add, we have now 3 properties here, user code and connection size. So let's just add adjustment value. We have air terminals with dampers, so let's add one more property there for those adjustment values. So I will just modify the name a bit so I will know what this tag is about. So damper position, then I'll just pick the property from the list, and I'll put it on a new line. Here in the preview you can see how it looks like, and also I can do some modification here. I can select if there's going to be a rectangle or a circle around the properties, or if I want to have or what kind of reference line I want to use. So I will use a target line there. And OK. Another thing is that which of these dimension texts is set as active. This little asterisk here tells us that, and for each dimension text category that are according to the product classes, each one has one active tag. So when we are continuously placing tags, then it makes it easier to use the default active tag all the time. We can, of course, change it here with the set active functionality here if we want to choose it, when we want to select that which one of these is the active one. So let's use this tag that we just modified as the active one now. Close the project and go here in annotation section. We have dimension text, and we can, now that we selected the active tag, we can just continuously start placing the tags. Select an edge line of the device. In the same way, for ducts, the software recognizes the product class and selects the tag that is active for that. So in this case, it's just a dimension there for duct segments. For components, seems to be user code and size. So this dimension text tool is for placing the dimension texts one by one. In case we want to add multiple dimension texts at one go, we can do that with the automatic text function. In the same way here, we can define the active dimension text format. And in this case, if we want to add the texts for air devices, we can do that here and just select the air devices that we want to add the text for, and press enter. And there we go. Then we can modify the placement afterwards if needed. Here we can see the adjustment value for these extract air devices that has been calculated. So we can see it there in the tag, or the damper position in other words. Let's go on and do some reporting. For that, we need to define report templates. So let's go to the ventilation report template. First, we'll have to decide which objects we want to include, all the object types in this report. Then we'll need to select the properties that we want to report. We could, for instance, search for We could, for instance, search for a number of similar. So we'll get an object count into the report. Okay. Pick it and add it there. So in the list of properties. Let's click on OK and close. And the reporting tools are located here. So we'll just take the report, select the template and the range. Let's take current drawing, and here also limit the range a bit by just taking now the supply system and click on OK. And we will get the report. Here we can decide how to sort the report. And for instance, here we can see that one duct size is reported here with its total length. And we can print the report or use it or open it in Excel, for instance. It is also possible to add in the drawing as a block, for instance.